In this video, I'm going to go over graphing piecewise functions. Now, piecewise functions are a little different from normal functions because they kind of change up the rules of the function depending on where you're at in the domain of your function, depending on the input. The I want to say range, but that's not the right word. This is a domain. Depending on which input you use, if it does not fall under x is greater than 2, for example, then it won't be graphed. You know, if we do x equals 1, then we check this. We can't do 1. It has to be this first one. So how do we graph that? Well, let's start from the lowest value, right? It should be the very first line in your piecewise function when they list it. So f of x equals all three of these things if x is at a certain spot, or spots, plural, in your domain. So start with x squared if x is less than or equal to 1. Well, let's equal to 1, so let's actually plug the number 1 into x squared, which is 1 squared, which is just 1, right? So let's actually do a input output here. We put in 1, we get 1. 1 squared is 1, right? Okay, so 1, 1. We'll do a closed dot because it's less than or equal to. Okay. So if it's less than, then we need to keep in mind everything in the domain to the left of that, because left is less than. This is the negative x direction. So let's keep graphing it. What's 0? 0 is less than 1, right? So 0 squared is 0. Okay. Put a dot there. How about negative 1? Still less than 1, right? Negative 1 squared is positive 1 again. All right. What about negative 2? Negative 2 squared is 4, positive 4, so 2, 3, 4. Right there. Looks like a parabola, right? Yep. And we put an arrow at the end of it because it's everything less than 1, and it just keeps going. But on the other side, things change. If we wanted to put in 2, we can't. We can't use the x squared part. We have to use this. If x is 2, then f of x is 4. It's always 4. Okay. And in this domain, it's x is less than or equal to 2, so that's going to be a closed dot. What about 1? Well, it's everything that's greater than 1, because the x is on the greater side of that. But it doesn't equal 1. So if we put 1 in here, for this part, it's a kind of a separate. Let me write this part again. This part was f of x if x is less than or equal to 1. This part is f of x if 1 is less than x is less than or equal to 2. So it's different. When we put in 1 here, we still get 4 because it's always 4 there. So we go 1 up 4, and we have an open circle. Right? what does that mean? It means this graph was a parabola until it hit the 1, and then it became just x equals 4. It just became a straight horizontal line, slope of 0, right? Just became x equals 4. Up until 2, and then it switched again. So what if we did f of x if x is greater than 2? Well, we still got to put in 2, right? Just like we did here, because we want to see where it jumps to. And it's going to be an open dot because it's not or equal to, right? So 2 negative x is going to be negative 2, right? Okay, so 2, 1, 2. Okay. And well, this is mx plus b form, right? So it's just negative slope of negative 1. So it just goes down 1 over 1. Down 1 over 1. Badly drawn, but get the picture. And it goes on forever because it's everything greater than that. Right? Okay, so this is what a piecewise function will look like. It'll look like 3 different graphs in one, because it is. It is a, first you got a parabola, then you got a straight line, and then you got another straight line. It's just, you jump. One of the rules is that you can never have any part of this graph, overlapping the other graph, overlapping. It needs to pass the vertical line test. If you don't remember what that is, you can look at my previous video when I go over the vertical and horizontal line tests. But you cannot draw a straight line anywhere and cross 2 points, because it's not counting that point of positive 1, 4 up there, because it counts this one down here. It doesn't count it twice. You see, because your domain has only one output. You put in 1, you get 1 out. We just put in 1 here just to see where we needed to put our open circle. Does that make sense? Same thing here. We just put a 2 in there just so we could know where to put our open circle. We count 1.001. That is part of the next piece, but it's not part of the parabola. All right, I'll do one more example. All right, we'll do another example for practice. Practice makes perfect in math. So now our piecewise function has 3 new functions in it with 3 different domains than we had before. So let's start with x cubed. And let's start at -1, where it says we're supposed to be less than or equal to. Okay, so -1 is right here, right? So -1 cubed is -1, right? Because it's -1 times -1 times -1. Negatives cancel. So it's 1 times -1, right? And that is -1. So, too many ones there, I confused myself. So, -1, -1. Okay, and it's less than or equal to, so it's going to be a closed dot. What about -2? -2 cubed would be -8. Way down here. Whoa. It's the function of something cubed, a cubed function, would be kind of a parabola, except it would be like cut in half parabola, you know. Part of it is going up, the other part is going down. This is the part that's going down, right? Okay, so that takes care of the first section. Now, let's look at x minus 2. All right, we want to know where it starts at -1. -1 -1 minus 2 is what? -3? Okay, so the point would be -1, -3. That would be an open circle, right? Because it's not or equal to. And then what? mx plus b form, right? It's got a slope of 1 and a y-intercept of -2. 1, 1. There's that y-intercept. 1, 1. And where do we go to? To x equals 4. So we still got a ways to go. That's x equals 3. So last one. And it's an open circle again, right? It's not or equal to. You gotta watch out. Oh, no arrow. We have an or equal to here, but not here, not here, and not here either. So be careful. Your teacher might ask you, hey, what is the domain of this function, by the way? You would have to say from -infinity to 4, but not including 4. If you wanted the domain of the entire function. A piecewise function just takes that domain and cuts it into 3 nice pieces. But nevertheless, the domain of this entire piecewise function is everything but 4. All right, we do include -1. It's included right there, but not +4. Just a little side note there. All right. Now, negative square root of x if x is greater than 4. Don't really have to know what that graph looks like, but it's good if you have an idea in your head of what it's supposed to look like, because then you'll know what you're doing. And then there's a negative outside of it, so it's okay. We're not going to get any imaginary numbers because x is always greater than 4. And if x is greater than 0, then we're definitely not going to get any imaginary numbers. Just another domain side note there. That's square root is one of those things that could limit our domain. But anyways, let's plug in 4 and see what we get. So 4, square root of 4 is 2, right? So -2. 1, 2, 3, 4. 1, 2. Open circle again. All right. So the next number after that, 5. Whoa, okay. I don't know that exact number. That's not going to come out very neatly, is it? So let's just go for the next perfect square, which would be 9, right? So what's the square root of 9 is 3, with the negative outside of it is -3. So way over there is 9 somewhere. And it only goes down to here. So let's just do that with an arrow. Let me get the picture. And yes, that is what a square root should look like, especially if there's a negative in front of it. It should be going downwards and on forever. All right. What if they asked us for the range? Just a little side quiz. What would you say? Negative infinity, right? To what? 2? Right? All these numbers all the way up to 2. And we stop. And we do not include it, so it's parentheses. Thank you for watching.